Okay, so should we start? I think we can start. Okay, so after an amazing session before, my cat is here looking at things because, as you can see, robots will take over the world, and cats are the only thing that can stand in the way of robots because cats understand how to turn off wires and things like that. So let's give it a try. Some people think cats are evil. They're just the most intelligent beings in the world, much more than we are. Okay, and I am here in my cat's house. I'm not in my house, I'm in my cat's house. I just live here occasionally. The cat lives here every day, so it's her house, not mine. And she's been a very good companion to me. My name is André Melancia. I usually do a few sessions like this, and yes, I've done a few machine learning sessions for you recently, so this year, and we'll talk about this. So first of all, um, this session is the third session, so come with me if you want to learn ML. And one of the things we've been seeing lately is that apparently anyone who doesn't even know how to put up a button can actually become king. So, machines will eventually take over. We are that intelligent that we'll let them. Our only answer is cats. Cats will save us. So anyway, let's mention one quick thing. So in January and in May, if I'm not mistaken, yes. So we did two sessions. So the first session was machine learning using Azure ML. The second session was a bit more detailed on how to get started with machine learning. I will continue this onto the third session. So the first session had some technical issues with sharing the screen, etc. Second session was a bit more complete, and we started to explain what machine learning was, even without talking about the technology. And then I tried to do a few demos, but of course, given time, this was not perfect to fit in 1 hour. So we had to cut all of the demos short. And this one is session number 3, where we'll try to do mostly demos. Okay, so I'll give a very quick introduction about machine learning, the things that we mostly talked about on the second session, but then I'll move on to doing mostly demos, okay, because demos are fun. Okay, and as always, because we are using Teams, if you go somewhere to the menu on top, you can actually get live captions. So you can actually have translation. These are done using, internally anyway, these are done using cognitive services. That's another technology that's also available for you to use in the Microsoft's world that doesn't require you to do a lot of work. It's just using web services. So feel free to do it. This is here for free. The paid services are also very interesting, so also have a look at them. But let's move on. Okay, so first of all, if you have any questions, ask them at any time, okay? And I'll take any questions from the chat during this time. I will try to do as much demos as time allows, but in any case, any questions at any time, just ask using chat, using audio, anything is fine. I'm here to answer them, okay? So let's have a look at the actual stuff. So before, in the previous sessions, we were actually talking about machine learning and what it was. So machine learning, put in a simple way, is just algorithms. So if you are a developer, you'll pretty much understand algorithms, lines of code. It's not magic. Well, it is, but it's not something that requires some crazy intelligent robots. Anyone can do it. This is actually much more intuitive than you think. It just has to be explained properly, okay? So this is an example. I think I've shown this slide before. This is an example how you can do machine learning. And in this case here, you see this graphically, but the idea here is that this can be graphically, this can be using, Python scripts, R scripts, any other kind of language as well, ML.NET, which you can use with C#, for instance. So there's a lot of possibilities to do this, okay? And in this case specifically, let's explain how this works. So first of all, what is machine learning? Well, a machine will, the same way that we do, we go to school, we learn by repeatedly reading things, etc. And then we stick some ideas in our minds that the Earth is flat and stuff like that. And from that point on, we insist that the Earth will always be flat and those kind of things. Well, spoiler alert, well, we've seen that kind of thing. That's why machines will take over. People think that the Earth is flat. This is completely wrong, and you know this. Because if the Earth was flat, that means that we would be living in a two-dimensional world. We live in a three-dimensional world, so the Earth is cubed. Everyone knows this. Okay, so anyway, let's move on. Um, let's have a look at a typical machine learning workflow. So the trick here with any kind of workflow for machine learning, the magic, the most important advice I can give you is all of this is all fine, but the step number 2 is the most important step, okay? 80% of your success will depend on that step. So let's say you get data coming in, and if that data is wrong in some way, it will be fed to machine learning training in a wrong way, and then it will predict things wrong, okay? So I mentioned the last time I was here, I mentioned a few examples, like you shouldn't be using the birth date, you should be using the age of the person, not at the current time, but at the time that the person did something like bought a product, did some kind of event or action or something like that. Why? Because what is actually important is not the birth date of the person. Two people can be born at the same time and do completely different behaviors. I mentioned the behavior of buying a product, one in the year 2000, one in the year 2020, and if they were born in 1950, one would be 50 years old, the other one would be 70 years old. You cannot compare these two. These are not the same because they are 20 years apart. They have different age ranges when the action happens. Okay, so doing any kind of cleanup, preparation of data, transformation of data, etc. Feature engineering. So weird name. What's feature engineering? So feature is basically a column. Okay, so to keep it simple, sometimes all academic people, especially in the 70s, they came up with weird names. So we have for tables, you have rows, records, samples, messages, etc. And vertically, you have columns, you have features, you have fields, you have dimensions, you have measures, etc. if you are in the BI area. So it's just another weird name for something as simple as a column or a field. Okay, so feature engineering is one of the examples is for you to try to do a selection and decide which of the columns make sense to do machine learning training with. And there are a few boxes that you see like this that can actually do that. Okay, let's not go into details for that now, but you could. Anyway, part number 2 is the most important part. Okay, if you get good data, prepare it well, make it in the right format, make it rightly prepared, ignore all of the things that shouldn't really be there, like individual unique ID numbers and passport numbers and those kind of things that are unique, that have no relevance to the machine learning training itself. Things like your name. My name is André. There's a ton of Andrés all over the world, and honestly, it doesn't make a difference for machine learning training. Okay, you're not going to buy a product just because you're called André. Okay, unless the product has that name on it, but I'm assuming not. Anyway, how does this work? Let's start from scratch. You get one or more data sets, and this is data, can be a table with data, something like that. In some other cases, but we'll focus on tables, but in some other cases, this could be images, text with phrases that you say, audio as well, video even, so many things, but we'll focus on tabular text. This is the most interesting and probably the one you're going to use the most. For any of the other things like images, etc., you probably want to go to cognitive services first, but this is a completely different session. So you get your data first. So here you get some features with labels. This is a CSV file where you get something, and we have no idea what this training is about because it doesn't really say there in the screenshot, but we'll take our word for this. This can be like a bank loan, for instance. You're going to get a bank loan. You have a lot of different options, and there some of these options we'll talk about will be for instance, let's say your age, your how much money you make, what kind of job do you have, if you're married, if you have kids, if you have cats, that means you're an intelligent person, etc. So all of these things come to play, and then they will decide if they will give you the bank loan. So a yes or a no in the list, okay? And the list that you have here is not for predictions. The list that you have there is the list that happened in the past. So a person asked for a bank loan and they actually paid for the bank loan. So a yes or no was the paid yes or no. And this is what you're trying to predict. You want to get a yes or a no based on if you are getting the actual if history of someone that looks like you actually paid for the bank loan. Okay, so and then we'll figure out how this works. So let's assume that example. So first of all, you get the data, you do something with the data. So these two steps would be normalizing data, doing whatever. Well, we talked about this the last time, and then we have split data. Okay, so what is the split data? Before you start this training here, you typically have, if you are with the supervised scenario like this, where you already have the results in the data set with these labels. Labels is yet another word for the results. Okay, sometimes you call X the inputs, Y the outputs, or labels. So in this case, labels Y, the letter Y, or any output, or whatever you want to call it, result, that's the results. Okay, so you split your data, going back here, you split your data here into two parts. You have your block of data that goes into training, and ignore the second split. I'll explain this in a second. So the second block of training, you can have that one, and that actually works for training the data, typically around 70%, 80%, maybe 90% if you have it, and the remaining percent, 20%, whatever the number is, you use it to test that model to see if the results came out okay, right? And then you can evaluate the quality of the model here. Okay, now let's go back to this part. So this is something called a tuner model hyperparameters. That means that instead of doing one training, you're going to do like 10 trainings, 20 trainings, etc. Why? Because you can actually define a list of hyperparameters. Okay, and let's say that you are doing stuff with a decision tree, and you can specify how many decision trees you want to deploy so that you can do training using n number of decision trees, right? Or you can specify what's the size, maximum size in levels or leaves of each decision tree. You can define that. That's called a hyperparameter. So if you have a hyperparameter that says, oh look, I'm going to have 32 trees, 64 trees, 128 trees, that's going to be three options, right? And then you have some other hyperparameter, let's say the learning rate, and you can have 0.1, 0.2, and 0.5, and again that's another 3. So you multiply 3 by 3 and you get 9. Okay, so 9, you can run tune model hyperparameters 9 times. Okay, and they will run that 9 times. This additional split data is needed so that you can optimize the answers, same as you do with the score model here in the split data. Second one is also for testing of that hyperparameter tuning, but let's ignore that you have this here. But the hyperparameters are basically running this n number of times. And let's say that I have a cluster that can allow you up to 4 nodes at the same time. You have 9 trainings to do. So you do 4 the first time, and then you do once one is over, which doesn't have to be at the same time. Once one is over, you get another training going, and then you get 4 more trainings going as soon as the other ones are done, and then suddenly all of the 9 trainings are done. And as soon as they are done, each individual node will disappear, will turn itself off. You stop paying for it, and then you have the training done. And then you score. You can still score the model to figure out which one is best, but then the evaluate model here will typically tell you which hyperparameter, which model is best out of the ones that come out of this. One will be the ideal one, let's call it like that, and that will be let's say the best, and that will be evaluated. To evaluate these things, how do you evaluate these kind of things? So scoring is when you get the original data sets, the testing part of the data set has the right results, and then you compare that right result with the results that came out of scoring. So the result that came out of this magical machine learning model. Okay, and to do that, it's a bit complicated because it's never going to be 100%. A good machine learning model will be 90%, 95% accuracy if you're using accuracy as the measure, okay, as the measure for quality. Sometimes you use a different measure, like things. It's very typical to use root mean squared error because it's the distance between the prediction that you did and the actual value. So the smallest one you have, the smallest distances you have, that root mean squared error, the smaller it is, the better it is. So some of these are actually good if they're big, close to, let's say, 100%. Others are good if they're small, closer to zero, okay? But in the end, you evaluate what it is, okay? Let me go back again for a bit of training again and mention all of the types of algorithms. We'll have a few pages for this, but you can do regression, which is continuous numbers, classification, which is classes. I'll get back to that one in a second. And then you have clustering, associations, etc., to actually figure out associations between two scenarios, like multiple people. You want to aggregate them and understand if they buy the same product, and if they do, would they buy some other product as well? Those kind of things. Anomaly detection, etc., and many others, okay? But you can use some techniques of deep learning and neural networks. Deep learning and neural networks are not necessarily the algorithms. They are a means to an end, okay? So, for instance, all of these are algorithms that have a specific purpose, and then inside they can use deep learning, neural networks, decision trees, etc., part of all of this, okay? So this is actually a very complex world from your point of view. Think of it as you have a box. For instance, this one is neural network regression. So you're doing regression, finding a continuous number somewhere, but you're using neural networks. That means that you're probably going to do a lot of time for training. It takes a long time, but you get a good result, okay? Now, once you do this, you try to deploy a web service. I'm going to try to show you how this works here. And once this is done, once your applications, websites, even IoT devices, you can actually use them. But once this is all done, after 6 months, your data is going to have something called data drift, okay? So that means that the quality of the prediction will go lower. An example of that is when we had the pandemic, all of the machine learning models suddenly failed because, all of the trends all over the world completely changed. Everyone changed their lives. They had to do retraining of all of this. So step number 7 is retrain everything. You might want to clean up in a different way because the universe changed. So you have to fix things again in a different way. And then you redo all things all over again. So this is an endless cycle that, I don't know, in a normal situation, depends again on the company. Every 3 months, 6 months, something like that, you train again. Okay, but it might be more or less. Okay, so let's have a look at some things for machine learning. This is fairly recent, so you have a machine learning, for image recognition. They recognize one cow. Well, there's another one in the corner. Let's not go there. But they recognize one cow, and any human understands that this cow is very long. That means that probably provides more cow juice because they have long deposits, right? No, I'm kidding. This actually means that the machine learning training is not properly done because they assume that this is a possibility, and they don't limit the cow to a specific dimension, like a ratio or something like that. This can be fixed. You can set up boundaries for this, but the machine learning training is actually doing this right because they assume that there might be obstacles in front of the cows. We just don't expect them to be as long as this one, okay? So this can happen, okay? Anyway, we talked last time about regression. Just to review some slides, and regression is basically having a whole bunch of points. You have your input data here, and you're supposed to get your Y output data somewhere for a prediction. And in some cases, a straight line would be linear regression. That would be easy. Other cases, it's just a small curve like this. Other cases, the curve has to be weird and with a lot of polynomial formulas to actually calculate this. So this that you see here dynamically is the training actually running, and they will try to adjust the curve to fit it to fit all of the data better. And this is actually a good example of that. Some cases you have multidimensional results in which you don't have just one input, you have a whole bunch of inputs, like multiple dimensions, and then you have to get the result out. So that's also a possibility, okay? Be careful with this. Sometimes when you see the data might, the average of the data might be something as simple as this, okay? So don't see monsters and weird things in the data. Sometimes the data is as basic as average of this. The other example of the data source is like the average of all of that is like a straight line or something like that tells you nothing, okay? But in this case, the line probably looks kind of like this, okay, I'm assuming. So it is strange in any case, right? Anyway, we talked about classification using something called logistic regression. And please be careful, regression here doesn't mean the same regression as the other one. This is a classification model. You can actually classify in 0 or 100%, true or false, A or B, something like that. And if you have multi-class, like n-class models, like multi-class models, those will have A, B, C, D as answers, different options for answers. Like, do you like, what's that called? So some type of beverage. Okay, so you have beverages like, I don't know, 7-Up, and you have some others which are the competition that looks terrible, etc. You have 4 or 5, and then they will decide which one people like, etc., based on 4 or 5 options. Okay, so you can actually try something like that, and it might work. Again, something that I always mention: if you try to torture the data, it might actually confess a completely different value. Okay, so please be careful. Don't be the NSA and the CIA of torturing data for machine learning. Just try to understand what the data actually means, not what you want the data to mean. Okay, you can manipulate the data, but you shouldn't. Again, clustering, just to mention clustering for a bit, you aggregate things together. I did explain this a bit better in the other video, but for now I want to skip it because I want to show demos as much as possible. Again, another example of clustering, and then just a quick example of that you can use neural networks to run some kind of algorithms. Data starts in the input layer, it gets processed a whole bunch of times and repeatedly, etc., and then towards the end you get your outputs. This is not easy to implement, okay, but typically you have a black box that you have your inputs, you have your outputs, and things just work. Actually creating one of this is not easy. Okay, anyway, let's play around with some AI, and in most cases, let's hope that the AI is not just a bunch of ifs. Okay, so let's see what we have. Again, we have something called aka.ms, and I'm going to write this in the chat, aka.ms. It's actually down here, so see here, aka.ms /ml sheets. I'm going to write this in the chat, okay? And if you go here, you have always the most recent version of this. So regression algorithms, this one is fast. Some of these are slow, long training times, but the accuracy is better. So you can decide, do you want accuracy or do you want speed? And you adjust, okay? And you have 2-class models, multi-class models. You have clustering here. You have text analytics, image down here, anomaly detection, and so much more, okay? Let's jump into this. And yeah, so this is the part that we start to do our demos. And just to mention, anyone can do this, so it's easy. So give it a try. And just to mention this list, I mentioned this list before. So we're actually going to focus here on the Azure Machine Learning Workspace. Okay, there's still something called the Classic. You can still use it. Okay, it was maybe a bit more intuitive, but you should be using the Workspace. It's easy enough. And the focus here, it says something called the SDK, okay? And the Azure Machine Learning SDK is amazing, okay? For instance, you have things like the ML Flow, which is a library for you to do orchestration of machine learning trainings, etc. The Azure Machine Learning SDK does that and even more, so you should actually be using that instead, okay? So it supports Python, it kind of supports R, but if you want to, you can actually call on things to run in Spark and in other things as well. So you can call on Databricks, you can call on Synapse Analytics with Spark, You can call on HD inside with Spark, for instance. You can call on, well, you typically don't call on SQL Server, but you can also run machine learning trainings in any SQL Server version starting 2016 with R, or more recently with Python. And Python is probably going to be more of the future than R. This is just my opinion based on what I've been seeing in the last 2 or 3 years, but anything can change, and 5 years from now we can have this talking and this can be completely different. Okay, so anyway, let's have a look at the rest. So you can also have cognitive services, etc., but we'll have fun. Remember, even if you don't know these languages, the most important part is the libraries that these languages have. Like Python has some libraries, R has a lot of libraries, ML.NET also has libraries, so the trick is to use the libraries, not the language itself. Okay, so let's have a look and let's demo things. Okay, and this is the fun part. Now, do you need Azure? No. Okay, so we're going to talk about Azure ML. Many of the things you're going to see here could actually be done generically without the Azure machine learning workspace. You can do it on your computer in many cases, but this makes it much simpler if you use the SDK. Okay, so anyway, you can click on a free account here and get it for free. We know this, okay, and you get like 30 days credit for this, but for now, let's have a look on how to do this. Plus sign, let's create an Azure machine learning workspace. So I go here for machine learning, I write it down, and I immediately get Azure machine learning here. I select it. Please make sure it says Microsoft. There's a lot of machine learning going on. The publisher might not be Microsoft, and you are getting something that's not what you want. It has the same Microsoft. It's not the classic, by the way. There's also a classic one. It's not that one, it's this one. And then when you create, all you have to do is to say subscription. This is how you pay for things, okay? You might have some free trial. Resource group, you just create a resource group, whatever you want. So, crazy machines taking over, for instance, okay, and you give a workspace name. I've already created it because otherwise we would be here forever. And then region, you can create a region for this anywhere in the world, as close to you as possible. Be careful because the free accounts have some limitations about some regions, but apart from that, create it. As soon as you create something, immediately they will suggest creating storage accounts and all of this for you, which will be helpful. If you want to use one you already have, you can actually choose one of the other ones, so that's fine. Okay, all of the rest is basic, so allow it public access to a public IP address so that you can see it. You still have to log in with your username, so it's not a problem. Okay, I really don't want to talk about security today. I like security, but not today. But then review create, and then you click on the create button. Seems easy enough, right? As soon as this turns green, which probably won't, you can actually do that. Okay, now let's go for Azure machine learning, and I've created this already. Okay, so let's go for Azure machine learning, and I have here, so my Azure machine learning resource group. Skynet will take over everything. That's fine. All you have to do is to click here on the Launch Studio, and from this point on, let's have some fun. We have limited time, if I'm not mistaken, 10 more minutes. Is that correct? Please correct me if I'm wrong, but let's have a look at the amount of time we have for this. Okay, so stuff that we need to know down here. Computes, you can define one virtual machine, one or more, of course, virtual machines. All you have to do is to click on the new button, give it a name, something VM, give it a size. Small is good, okay, don't be careful with the prices. Small is good, all options are the recommended options, and then advanced settings, like you can add a shutdown and stuff like that. That's important. Just to give you an idea, I left this running for the last 2 days. I completely forgot. Okay, so this is new. You have to enable it in some setting up here because there's a preview thing. This is still a preview thing. So up here, they will give you a message saying, would you like to enable this shutdown as a preview? Yes. If you see this video in a few months, this will be here immediately, but that's fine. But so far, this is a preview. You say create, and that's done. You have a virtual machine. This virtual machine has Jupyter Lab, Jupyter Notebooks, Visual Studio Code, a command line terminal, and you can see the notebooks that you can actually see here on the left. We'll get into that in a second, okay? You can also create your own compute clusters, and these are a configuration where you specify either what type of CPU you want. So for instance, you can have normal CPUs, or you can use one that has GPUs, physical GPUs on them, like NVIDIA and stuff like that. and then you specify the size for each node, and then you specify the capacity, and you give it a name, of course, but then you specify minimum node 0, should always be 0, otherwise you keep paying for this 24 hours a day, and maximum certain number of nodes, more than 3 nodes, whatever. So yeah, that's okay. So idle seconds before scaling down, okay, and then you say create. It's not available here because I didn't fill in all of the information, but you can say create, okay? In some of the examples we have here, we can use the wizards to create the cluster instead of doing this ourselves. Now, inference clusters is how you create clusters so that you can do predictions, okay? In this case, you can create a Kubernetes cluster or use an existing one, but you can also deploy your machine learning, inference to containers in Azure Container Instance. In this case, you don't create anything. It will be an individual, container floating around in the cloud somewhere, created by Azure on the fly. It doesn't really have an existence in one infrastructure that you create. It's just randomly there in the cloud. You get an address for it, and it just works. Okay. You can also associate with other things that we will talk about, not me, but someone else will talk about previous session and the next sessions in here. Things like Databricks, things like Synapse Analytics with Spark, HD Inside with Spark, and Kubernetes. Again, you can process things or even create a virtual machine by yourself and put stuff in it so that you can run something. And the Azure Machine Learning SDK will help you interact with that machine. Okay, so you can also create data stores and actually create the data stores coming in from either a SQL database, Postgres, MySQL, MariaDB, or from blob storage to actually get files. Okay, so you can actually create as much as you want to associate with your own sources of data. This makes perfect sense. You should do this. Okay, so you create your own a data store, same as if you had a link service in Synapse, for instance. These are basically, here you just store the equivalent of a connection string. Okay, all of the magic is you connect using that connection string and you get some data. And here data I have a sample called diabetes. I'll show you how to create this in a second. I have another sample called modified something that I've created for binary classification, and we'll have a look at this. So explore, so preview. So I have some files here, etc. Okay, but we'll get into that a bit later. Okay, so sample diabetes. How do I get that one? I can go here, create from open data sets, and then I have my sample diabetes, but many others. So I can just click here, click on next, save it here, and suddenly I have a sample here that's available for me to use. Okay, so this is simple enough. Okay, now I have more things. So another linked services, data labeling for, defining labels on data for data protection and stuff like that. Less interesting today, but now let's focus on the three things that we have here. We can do it with notebooks and codes, typically Python. We can do it with AutoML, which is completely automatic. I've shown this the last time. So let's start with that. So new AutoML job. I ran the diabetes already, but let's start it. So create an open data set like the one for the diabetes, select it, click on next, and then run it. So this is easy enough. Last time I've shown this, so this was easy. You create a new experiment, give it a name, click on next a few times. You select a cluster or your own individual VM instance. In this case, it runs better on a cluster. I actually have two here. One of them is cheaper than the other, but let's not go there. And then I click on next a bunch of times, set up all of the remaining stuff that I need to run in terms of configuration, etc. Very basic, and the nice wizard will generate this. Okay. So by the way, these names are random names, like first word, second words, and they come up with funny names. But this is just for human consumption, because instead of that they could say run 1 2 3 4 5, and that's less fun, so they decided to use it like this. Okay, but anyway, it says completed. It ran like for 40-50 minutes, and then I can actually see all of the results. So all of these results actually run. I can still go for overview and see all of the details for output models, etc. And the models are here. So this ran, and this one apparently was the selected one. We know because not only do we have the best results here, the lowest results, normalized root mean squared error has the lowest results out of all of this, but at the same time they automatically generated an explanation. Explanation is how you can detect. This is like you associate an explainer, and that explainer allows you to understand on a global level what kind of fields are more relevant or less relevant for your results. And you can have a global explainer for the whole thing and say, oh, if I'm doing diabetes, for instance, the body mass index, how fat you are, okay, that actually has a lot of relevance. But if you are using local explainer, you get like a web service where you fill your data, you get a result out, and the local explainer will tell you for you specifically the most relevant field was this one. Okay, so explainer is also a good thing, but this is for another time to talk about this. Okay, we have very little time for this because we still have like 5 minutes or something like that. Okay, so anyway, all of the child jobs, one got selected, and then you can see the jobs here. So I ran a whole bunch of jobs here, okay? And one of the things that you can do is once you save that model, so I'm going to go here, you go here and models, and then you can actually say register the model, okay? And that model gets registered here, okay? So you can actually save the model in our model list. You can do this with codes, okay? And in my case, I have a few of them that I deployed based on some of these things, okay? And one of the things that I did was, this one is actually not good if I can tell. This one, let me see which one is best. So you can actually click on the model, click on deploy, and run to a real-time web service, okay? So I have quite a few of them here, and then I created 2 or 3 endpoints for this, okay? Actually, the one that's bad is this one. I think this one is actually good. So let me confirm. No, this one failed. Okay, so going back to that loan thing, I'll try the loan thing instead. So the loan thing is actually a bit better to give you an example of how to run a web service, okay? So I can actually have my income, and how did I get my income one? Let me actually start from beginning. So I actually took this sample here of something income, binary classification with feature selection income. I changed that to make it much simpler. Okay, and I said Andy modified one training here. Okay, so I made it much simpler. Okay, so pretty much removed some of the things that I didn't want. So I started with my data. You can right click and say preview data if you want to. Okay, and you have all of the data here. So age, work class, education, marital status, occupation, race, gender, and income. So income is your output, which is going to be less or more than that value. Okay, native country and stuff like that, number of hours per week. The peak here is obviously 40 hours per week, but you have a lot of different values here. Okay, so once you try to see this, you split the data. In this case, it says 50% each way. That's fine. You can actually click on this, see settings, and adjust the value. Oh, too much. Okay. Split data, and you can actually, oh, sorry, it says 70%. I did change it. I just didn't change the text. Sorry about that. Okay. And then this one goes for the testing, for the scoring that you test. Okay. However, this one still takes all of the fields and selects the top fields based on some techniques, scoring methods, some techniques. They choose the top fields that you want, in this case 5, to feed to the machine learning training and ignore the rest, okay? Then you actually train the model using a 2-class boosted decision tree. You can specify number of leaves per tree, number of samples per leaves, learning rates, number of trees constructed, etc. So you can define these numbers. In this case, we're defining only one, but if I expanded this, I can actually have a box that says tune model hyperparameter here somewhere, and I can actually drag it and do the same as the other drawing that we saw before, okay? So anyway, I trained the model, and then this all runs. So if I click on submit, I did this before. If I click on submit, everything will turn to green, and then there will be a button here. So sorry if we cannot see it. There will be a button here that says create a real-time inference experiment. And wait a minute. Yes. and you can actually create this one, real-time inference experiments. That's it is a button that you had somewhere on top. Okay, then you submit this, and again, sorry for this not being green because the interface doesn't show me green, but you run this. As soon as you submit this, this all turns to green, and there's an additional button here that says deploy. Okay, and this is how I deploy these two endpoints that say income. Okay, so I will try just one. So testing. So I have, let's say, tests, okay? And this actually has a lot of them. So 1, 2, 3, 4. So let's take just the top one, okay? So the result probability is going to be less than 50,000 gold coins of income. So that might be bad. It could be, don't give them the bank loan, but the probabilities are very low. So that's okay. But I have a trick here. If I say capital gain like this, so assume that the guy is rich. If I say tests, then they will give him the bank loan, which is much bigger. Okay, if you have a bigger value, they will give you a much bigger bank loan. Okay, they will guarantee the bank loan. So you can test it here in real time if you want to. You can actually consume it, and this is the part that I want to get to. If you want to use your own applications, let's say C#, but also Python and R and any other, you can copy paste this example here, and this is literally an example you can copy paste, and then you say, look, get all of this, get all the data in here, and they give you an example already, and then all you have to do is to run with a certain API key, which is the one I should be using, etc. You can actually run all of this and then get a response from posting that message into HTTP requests, and then you get, if you get the result, you get this. If you fill the result, you get that. But then you use the result of true, false, whatever in your own application. Okay, we are exceeding our time. I do apologize for to the next speaker. Okay, let me just finish this up by saying something as homework if you want to try it. We have a lot of sample here for tutorials, okay? So last time I suggested image classification MNISTs. This time I'm just going to suggest that you try a simple one, which is training. And then training on AML computes. You can actually click on this and say clone. Another one that you can clone, and this is highly recommended, I'll put this in the chat. You can actually go here for files, open up your terminal, and remember that in your terminal, you're accessing that VM that you have there. You can even do htop if you want to and see things. Remember, this is an Ubuntu. This is an Ubuntu modified by Microsoft, but one of the things I want to show you is to do this. You can actually say git clone this. I already have it, okay? So I git cloned this address, and this address is actually very nice because you can git clone the address, which is the official Microsoft course for this, and just follow each of these notebooks one by one, okay? Do one by one. For instance, real-time inferencing and creating a web service, you can actually do it with this. And just to give an idea how easy it is, let me jump into this. Most of this has already run, but just most of this, all you have to do is to do this. So you have some kind of, up here, you have some kind of script file that actually initializes the file and gets the model, and then runs the model based on the inputs of the web service, which is the raw data, gets you the result out. This is very easy. How do you deploy it? You say ACI web service deploy configuration, and then you say model.deploy. This is just as easy as that. Job done, okay? And then you can go to your endpoints and have a look. Only thing I'm going to tell you is if you run this in one straight go, make sure you delete last line where the service actually gets deleted. Comment this out. Otherwise, when you run the whole thing in one go, you go to the endpoints and nothing is there, okay? So because we are running out of time, I'm gonna, if you have any questions, please ask the questions in the chat, and over the next session, I will be happy to answer them. I'll be around, okay? But we have exceeded our time, so I want to go back and wrap this up, okay? So again, if you have any questions, either ask them in the chat during the next sessions, or or ask me later on in reach out to me in any way you would like, okay? So yet another session on machine learning. One last advice: machine learning is something that most universities are teaching now. Even if not an advanced level, you're not expected to know how to create the anything that's inside the algorithm. So for you, it's a black box, but you are now expected, as developers, you are now expected to learn machine learning and use machine learning. Okay, so everyone, thank you very much for watching. Apologies to the next speaker for running a bit out of time, 5 minutes out of time. But in any case, thank you all very much, and have some fun in these amazing upcoming sessions as well. Okay, thank you very much, Hassan, for inviting me again.